All right, here we are in video number 4. We're going to do example 3 as a recap of video number 3, which is, can we evaluate this limit by direct substitution? Now, if you'll notice, example number 3 is on the multiple choice, so you don't have to be, I guess, as um, specific or like this. You're trying to do these quickly, right? So this whole idea of writing things out, you don't have to do that. Let's just substitute 2 into the numerator and see what we get. So 2 squared plus 2 minus 6. That's going to give us 0. And then substitute 2 into the denominator. 2 squared minus 4, well, that's going to give us 0. That's an indeterminate form. So that means we have to be able to factor that out. Okay, well, remember, we're approaching 2. 2 is causing the issue. So what I'm guessing is x minus 2. Now, there's something else, but x minus 2 is one of the factors. And I'm guessing that because if I plugged in 2 and that was the problem that caused a 0 on top and 0 on bottom, then there must be a common factor on top and bottom that relates to x equals 2, and that's the factor x minus 2, right? If I plug in 2 into that factor on top, 0, same thing on the bottom. So then what's left? Well, on the other side, or on the denominator, to factor out x squared minus 4, this would have to be x plus 2. And then in the numerator, this would have to be x plus 3. We can reduce these. Those are now gone. And now take the limit. And because we're just writing things out here because it's a multiple choice, I'm substituting 2 into the numerator. I'm substituting 2 into the denominator. And we have our answer right there. When you get 0 over 0, that doesn't mean there isn't an answer. That means you need to try something else. And so the second thing you could try is rationalizing. Because if you look at this example in example 4, part A, you can't factor this, right? Or at least not obviously. There isn't an obvious way you can factor. So what we're going to do is we're going to rationalize it. Well, first, is it giving us, we don't need to rationalize if we get an answer, so we should check. Does the limit as x approaches 0 of the numerator give me 0? If I were to plug in 0 wherever I see an x, yes, I get 0. If I take the limit of the denominator as x approaches 0, does it give me 0? Yes. Okay, so this is an indeterminate form. So how do we get around that? We play this very, very clever technique, I think. I've always thought this is a clever way to do this. We look at the part, whether it's a numerator or denominator, that has the square root, where I'm either adding two things or subtracting two things, where I'm subtracting two things, right? I have something minus something. We're going to multiply by the conjugate of that. The conjugate. The conjugate are the same two things I circled, but with the opposite operation. So the conjugate would be the square root of x plus 1, because that's the first term, and 1, because that's the second term. But instead of subtraction, we're adding. So we're going to multiply this times the original numerator. But if I do it in the numerator, I got to do it in the denominator. So I'm going to multiply the bottom by the conjugate as well. The conjugate of the numerator, or the conjugate of the part that has the square root. Why do we multiply by the conjugate? Well, if you forgot, and a lot of students forget, I'll do an easy conjugate. X plus 3, the conjugate would be the same things except with the opposite operation, so x minus 3. When you multiply these two and you multiply these two, but remember, we also need to multiply these and the inner ones here. What happens to the outer in purple and the inner in purple when I multiply them? What happens to this? Well, they go away. They cancel each other out. And I'm just left with the product of the first terms minus the product of the second terms. So when I come over here, if I multiply, and I'll use green here, I'm going to multiply that times that. The square root of x plus 1 times the square root of x plus 1 is just x plus 1. And then I'm going to multiply that times that, and that's just going to give me minus 1, because if I were to multiply these inner ones, I would get negative square root of x plus 1. But if I multiply the outsides, I'd get positive square root of x plus 1s, and they're going to cancel out anyway. So this is all I get. So if I continue the limit statement, as x approaches 0, in the denominator, I'm not going to multiply that out. I'm not going to distribute that. I'm just going to say x times square root of x plus 1 plus 1. Now, something nice is going to happen, and this is where the cleverness comes into play. What happens when I add 1 and subtract 1? What am I left with? I'm just left with the x, because these cancel, right? Plus 1 minus 1 cancel. And then in the denominator, I purposely didn't multiply that x out because it is going to reduce out with the x that's in the numerator. So this x and this x are going to go away. Now be careful. There was an x on top, and I'm going to reduce it out. That means there needs to be a placeholder in the numerator, and that placeholder is a 1. And then in the denominator, I'm left with this. All right, so wait. We started with the original limit over here that had the square root of x plus 1 minus 1 over x. And now we have 1 over the square root of x plus 1 plus 1. If we evaluated doing direct substitution, plug in the 0 wherever you see a 0, wherever you see an x, you're going to get and that's your answer. Remember, we did this because we got a 0 limit on top and a 0 limit on the bottom. That's an indeterminate. Indeterminate means there is an answer, maybe, actually most of the time. I just need to do it another way to figure it out. And whenever you have square roots, the quickest way to do that is to do conjugates. So if you know you have an indeterminate form and you have square roots and you can't factor, try multiplying by the conjugate, top and bottom, and then reducing that out. I'm going to pause this video, and I'll come back in the next video to show you part B.